Hi, Andrew here again with my further experiments with Geogebra. I was essentially wanting to get something that worked with Geogebra 3D and Geogebra augmented reality, which included some tracking of the viewpoint, essentially the camera location. Essentially so that we can do things like this, have something which will change the actual geometry of the shape depending on where you're looking at it from. So you can get this illusion of that one part passes over another, and in reality it's just a gap that's cut through that vertical bar at the front there. Of course, to do this precisely, you need to know where the camera is. And the way this does this is, actually I'll show you, it's in this expression here. It tracks a thing called corner -111, which is essentially the 3D coordinates of the camera. All right, so this gives me quite a nice little object in GeoGebra. I just wanted to see if this thing would then work in the iPad application, GeoGebra 3D, and whether it worked within the augmented reality part of that. So that's the next thing. I'll go over to the GeoGebra 3D app on my iPad and show you what it looks like there. Here we are in GeoGebra 3D. I'll do the usual thing of opening files with my surname, and here is the cube, and we can see that it works quite nicely in GeoGebra 3D, right? So I can rotate it just the same as within the app. Now the disappointing thing is I was hoping this would work in augmented reality. So let's give that a go. Hit the augmented reality button and I'll put it here on my desk. And I've got a messy desk, but you'll notice that it's not even changing the view to include some of the surfaces at the back that I've turned off. So what I can deduce from this is that the augmented reality functionality within the GeoGebra 3D iPad app doesn't include the camera location as that corner -111 point within the system, which is a bit unfortunate. It'd be lovely if it did, but in this case it doesn't. Okay, the other one I wanted to show you was another ambiguous 3D object, which is famous Penrose Triangle, which is available with a range of options. And again, a little bit of the geometry you can edit from within the controllers here. But the surprising thing about this is that this is a Penrose Triangle that you can actually rotate around and it will adapt. Again, it does this by knowing where the camera is and changing the length of these bars. If you're interested, dive into the code and figure out how I did it. Again, I'm interested whether this one can work within the iPad app, and this one works fine in the GeoGebra 3D app, but the GeoGebra augmented reality, it fails rather badly. So I'll show you that. The Penrose Triangle with rotation. Okay, let's zoom out a bit, and you can notice that it doesn't like terribly much rotation. It ends up in very ambiguous ways, but it can take a small amount of rotation. This is just me rotating it with my finger. I'll just get it into a reasonable view. Let's put it in augmented reality again. Let's place it on the surface, and you can see it's really quite badly mangled. It's not showing anything much at all, and as best I can figure, it doesn't actually do anything to pick up any changes in perspective. So the geometry doesn't adapt as it does in the GeoGebra 3D app. So yeah, quite a nice Penrose Triangle, but it doesn't work in as hoped in the GeoGebra 3D augmented reality.